contribution would be greatly appreciated as well. Okay, so here we go. You will have questions like this on the exam, and these are going to be worth each maybe 2 to 4 points, so you don't want to miss out on them. Number 1, we got to look at the patterns. So I noticed 2, 5, 8, and 11. The first thing I want to do is draw an arrow. Okay, 5 to get to 8, 8 to get to 11, and that pattern continues. Raise your hand if you know what's happening. What is the pattern? Yes, Simon. Add 3 each time. Very good job. So, let's check. 2 plus 3 makes 5. 5 plus 3 makes 8. 8 plus 3 makes 11. Fantastic. Well, to get the next 2 numbers, I do 11 plus 3, which makes 14. And then 14 plus 3 makes 17. You can always use a calculator, or you can use your brain calculator for that. All right? And since we're consistently adding by 3, is this arithmetic or geometric? If we're consistently adding, arithmetic or geometric?
Arithmetic.
Yes, remember, that was unit 2, where we said if we were adding or subtracting, that is arithmetic. If we were multiplying by a whole number or multiplying by a fraction less than 1, but bigger than 0, that was geometric. Well, let's look at the next one. Let's go ahead and see if we can get a volunteer here. Micah?
Negative 48, negative 96.
So, can you tell us what the pattern is first?
Negative 2.
Times, and then let me just go ahead and stop you right there. We know that a
Or
negative
two.
times a negative is a positive, but here we have a negative, so it can't be negative 2. It has to be a positive 2. Very good job. And let's check his work, right? Negative 3 times 2. Yep, that makes negative 6. Negative 6 times 2, that makes negative 12. And negative 12 times 2, that makes negative 24. Negative 24 times 2, that is a negative 48. Negative 48 times 2, that is a negative. Plug it into your calculator. Let's see. I'm making eye contact with a lot of you. Yes, Kingston. Negative 96. Okay, plug it in your calculator if you don't know. Is this arithmetic or geometric, Kyle? If you're multiplying by 2.
Geo.
Yes, geometric. Good job. Number 3. Anybody want to give that a shot? Tell me what the pattern is first. Kate, do you mind telling me? Definitely, numbers are going down. All right, let's check. Divide by 2. 80 divided by 2, or half of 80, is 40. Good. Another way to express that is multiplying by 1/2, right? So 40 times a half, or half of 40, is equal to 20. Half of 20 is equal to 10. And then what's half of 10? Class?
5.
And what's half of 5? 2.5. There you go. Is this, Kate, geometric or arithmetic? Very good job. We're multiplying there. Good job, guys. Number 4. Who is going to give me that one? That pattern right there. Yes, Zach.
Add 5.
Add 5. Okay, let's check. Negative 50 plus 5. Oh yeah, I moved to the right 5 times. Negative 45. Moved to the right 5 more times. Negative 40. And a student last period told me, well, if you're getting closer and closer to 0, that means you're adding, right? You're going to the right. Okay, so that was really cool how they thought about it. And therefore, the next 2 numbers are negative 35 plus 5, negative 30, negative 25. Is this arithmetic or geometric? Thank you so much. You're adding by 5. Arithmetic. Thumbs up if that makes sense. Okay, let's do number 5 together. Write an equation for each of the following geometric sequences. So let's go ahead and go with 30, 60, 120, 240. Wow. I always give you the first number. I always give you the second number in the list, the third, and the fourth. But I don't give you the 0th spot. You have to do that on your own. You will need to draw a little line with a little comma. And some of you might even want to put a question mark there. You need to find out what that number is. Because the 0 spot is our initial value. It is our y-intercept. It is important. Okay. Let's go ahead and use our patterns to get us that missing number. What is happening here? Daniel, what's the pattern? 30 to get to 60, 60 to 120.
Times 2.
Times 2. Let's see if this agrees with what we're thinking. Oh, okay. I like it. 30 times 2 makes 60. 60 times 2 makes 120, and then makes 120, and then 120 times 2 makes 240. So that is our multiplier, or our common ratio. All right, I'm going to put that number there. I know you're multiplying because I called it a multiplier. So all you got to do is write down the number 2. What is, did you get a tattoo?
No, it's from Halloween.
Oh my goodness. Sorry, it looked too real from back here. The 0 spot. So the 0 spot is we need to get that number to the left of 30. Well, multiplying by 2 is in the forwards direction. Now we gotta divide by 2. What is 30 divided by 2? 15. So now we have our 0 spot number and we have our multiplier, 2. How do I write an equation for this? I definitely need an equal sign. I need a y and I need an x. Input, output. You always do y equals the starting value, your 0 spot, which is 15, parenthesis, times 2 to the power of x. That is how you write exponential functions. Okay? Take your initial value and you're constantly multiplying 2 to the power of x. Any questions? Can we do number 6, 7, and 8? I'll give you about 1 minute to brainstorm. See if you can do 6, 7, and 8. And then I'll call on a few people. All right, here we go. Let's go with number 6. Okay, so let's go with Adziri. For number 6, what is the pattern? Tell me the operation. So adding, subtracting, multiplying, or dividing. Multiplying by what? Okay, multiplying by 1 over 3, and we know that's the same thing as dividing by 3. Okay, let's take a look at that. All right, 54, type it in your calculator, divide by 3, that makes 18. 18 divided by 3, that makes 6. And 6 divided by 3 makes 2. So that is correct. And we know that dividing by 3 is the same thing as multiplying by a third. So that is your constant multiplier. How will I find my 0th spot? I go backwards. Instead of dividing by 3, I am going to multiply by 3. Plug that into your calculator. 54 times 3, that makes 162. So now, can Kira, you tell me the equation of this sequence?
I equals 162. That's 3x to the power of x.
It's your multiplier is 1 over 3. Right? Because you're dividing by 3. So that means multiplying by a third. So it's 1 over 3 to the power of x. Good, 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 good. So we're learning from each other. And we got to make sure if you're dividing by 3, you write it as a fraction. 1 over 3. Okay. Let's do number 7 now. 12, 48, 192, 769. Micah, can you tell us what you got for the pattern?
For the pattern, 4.
Give me the operation. We're like doctors, right? You can't just tell a patient, hey, you have heart. And they're going to be like, heart what? You know, a heart problem, a heart something. Like you have to, in math, we have like tools and they're adding, subtracting, multiplying, dividing. So what are they?
Multiply by 4.
Multiply by 4. Good job. There you go. Awesome. And let's check his work. 48 times 4, that makes 192. That's what my calculator got. And then 192 times 4, I got 768. So now how did you find the 0 spot? Micah?
Just divide it by 3, divide by 12 by 7.
Divided 12 by 4. Good job. To get 3. Very good job. So my equation, therefore, is you got to have a y and an equal sign. Y equals starting value 3 times 4 to the power of x. You got your input and you got your output. Let's go ahead and do number 8. All right. Can I get Charlotte? Tell me what the pattern is for number 8.
Multiplying by 1 over 4 divided by 2.
Oh, dividing by 4 or multiplying by 1 over 4. I like that. So 32 divided by 4, that makes 8. 8 divided by 4 is 2. And 2 divided by 4 makes 1/2. So my common ratio is 1 over 4. Charlotte, so how do I get my 0 spot? You multiply by 4. And what is 32 times 4? 32 times 4 makes 128. So what's my equation then?
Y equals 128. I don't know how to say.
To the power of x. Okay? Alrighties, very good job. Now let's go ahead and do numbers 9 through 11. And this is 100% on the exam. So this entire page is setting you up for success. I need you to first find the pattern in the y's and then see if you can find the 0 spot. Sometimes the 0 spot is given to you, but sometimes it isn't. Okay, here is our 0 spot given to us in question 9.
Yeah.
Okay, so great. I kind of made you do less work there. So let's go with Mick. What is the pattern here for number 9?
Multiplying by 3.
Okay, that 4 times 3 makes 12. 12 times 3 makes 36. So yes, that is correct. Can you tell me, therefore, what my equation looks like?
Y equals 4 parentheses 3 to the power of x.
Excellent. Now let's go with number 10. Ooh, 625, 125. Then then you get 25, and then you get 5, and then 1. Let's go with someone over here. Diego. What is happening here?
Dividing itself.
You're dividing, yes, by what number? 5. So 625 divided by 5 is 125, and then it's the same thing as multiplying by 1/5, multiply by 1/5, and then you multiply by 1/5. Very good job. Is our 0 spot given to us, class? Our 0 spot. Yes, our y-intercept is there. Great. So we have our starting number and our multiplier, so we're good to go. So tell me, Diego, what my equation is.
Y equals 1/2 over 5.
No, not yet. It's the initial value first. It's in yellow.
625. And then 1/5.
Times 1/5 to the power of x. Okay, just like the previous problem, same format. Good job. Now let's do number 11. Any volunteers for that one? Piper?
Is the pattern of the equation?
Let's do the pattern first, and then, then you can tell me the equation.
Multiply by 4.
Multiply by 4. Let's see. 20 times 4, that makes 80. Good job. And then 80 times 4, that makes 320. So everything looks great. Do I have my 0 spot given to me?
No.
I don't. So therefore, I need to find it. And I'm just going to make a little spot for it over here. So how did you find it?
20 divided by 4.
And what is 20 divided by 4?
5.
5. And then you see how you can go backwards and you get the 0 spot is 5. And what's your equation look like then?
Y equals 5 parentheses 4 to the power of x.
That is correct. When you're done, turn the page. I'll leave this up for a few more seconds. Okay, so number 12. So we're on page 2, and this question is going to be on the exam, and it's going to be straightforward. It's going to be identical except with different numbers. When you're asked for exponential growth or decay, I always want you to look at the constant multiplier, okay? So what is it equal to? Is it a whole number, or is it a number less than 1 but greater than 0? So let's take a look. 1/4. Plug it in your calculator. That's 0.25. You're constantly multiplying by 1/4. Are you growing or decaying? If you're constantly multiplying by 1/4, this is the same thing as divide by 4. Simon.
Decay, probably.
Yes. The reason is, guys, times 1/4 is the same thing as dividing by 4. Think about a number like, let's start with 30. 30, or I guess that's a little too much. Let's do, I guess we can start with 16. I think 16 is a beautiful number. 16 and then divided by 4. What does that equal? 4. So you went from 16 to the number 4. You got smaller. So when you're dividing, your numbers get smaller, 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 smaller. So that means you are decaying, okay? And that is because the b value, the base, is less than 1 but greater than 0. Plug in 5/4 into your calculator. 5 divided by 4. What do you get here? 1.25, which is a number that is bigger than 1. You're multiplying by a number that's bigger than 1, so therefore this is growth, okay? It's like taking the number 3 and multiplying it by 2. That makes 6. You went from 3 to 6. You're growing. Another way to do this, 5 is bigger than the denominator, right? Whenever a number in the numerator is bigger than the denominator, that means you are growing, okay? So therefore, 4 over 3, is that growth or is that decay? 4 over 3. The numerator, you're more than one whole, right? 3 over 3 would represent one whole, but that's 4 over 3. So this is growth. B is greater than 1. What about 1/2? The denominator is bigger than the numerator. So therefore, this is what? Growth or decay, guys? It's 0.5, right? It's dividing by 2, divided by 2. It's decay because the B is between 0 and 1. What about 7 over 3? Why is it growth? Yeah, you're bigger than the whole, right? So 3 over 3 we know is one whole. If you're 7 over 3, you're way bigger than the whole. Okay, there's going to be a question like that on the exam, 2 of them. So let's do number 13 and 14 together. Number 13, you need to find the corner points. I only want you to find 3 corner points, okay? So here is my first step. I'm going to look at the graph. I notice my y-intercept is a nice corner point. At -1, I have a y value of 1. And then I'm going to look to the right. At 1, x value of 1, you have a y value of 4. Those are nice corner points right there. I'm going to highlight my x's here with their corresponding y values. There you go, in blue. So, if you guys have that right there, I am going to write those numbers, those ordered pairs, on the table. And always start with your smallest to largest, okay? So my smallest x value is -1, and it's paired up with the y value of 1. And then 0 for the input, I get an output of 2, so it's matched up with 2. And then I have x equals 1, and it's matched up to 4. Okay. I need to write an equation, so why don't we go ahead and figure out what's happening with the pattern. From 1 to 2, what am I doing? And from 2 to 4, what am I doing?
Multiplying by 2.
Multiplying by 2. Do you guys see how this is exponential? It's a curve, so you are multiplying because you have exponential, and it's a whole number because you're growing. So times 2 times 2. So then, therefore, the y-intercept, therefore, the common ratio is 2. What is my y-intercept then?
2.
It's given to you. It's at 2. Can someone give me the equation for this?
Y equals 2 times 2 to the power of x.
Very good job. Excellent. Okay, let's do the next one. Let's look at the corner points. And first of all, is this growth or decay, guys, if you're reading this from left to right? You step into the roller coaster. You're going down, okay, down the curvy roller coaster. So this should be multiplying by a number less than 1. Corner points first. I don't want to get carried away with myself. 3 points is perfect. Daniel, did you already plot your points there? Okay. Corresponding y values. Okay. So we get x value, smallest x is -2. It's paired up with a 4. And then I get the next x is a -1, and it's paired up with 2. And I get 0, and it's paired up with 1. What is my pattern? Multiplying by what number? Or maybe you can start with dividing by one number. Since we are decaying, yes, Tegan. Yes, you times by 1 over 2, or in other words, you divide by 2. Thank you, Tegan. So that is our multiplier, or our common ratio, 1 over 2. And are we given the y-intercept? What do you guys think? Yeah. So Mick, tell me my equation.
Y equals 1 parentheses 1/2 to the power of x.
Good job. The number 1 can be invisible whenever we multiply by 1, okay? So 1 times x, we know we can just rewrite that as just x. So we can rewrite this as y equals 1/2 to the power of x. We know that there's a 1 there because we can make it invisible. Turn the page when you're ready. Oh, I'll leave this up for a second. Let's go to number 15. So, is this already page 3? Oh, wow. Okay, let's look at the time. Great. So, for these problems, they're going to be on the paper test, okay? So, what I need you to do is always look at your constant multiplier. Excuse me. Okay. So constant multiplier is 3. So when you look at your y column, you're going to make sure that each of your numbers are getting multiplied by 3 in the forwards direction. So times 3 times 3 times 3 times 3. Write this down. This is very helpful, okay? I have a career in math, right? And I became this successful because my teachers taught me a lot of skills. So you should take the same skills that I'm teaching you with you, right? So one more important fact is, are we able to find our y-intercept based on that equation?
Yeah.
What is it?
1.
Yes, 1. I told you guys that that 1 can be invisible when you multiply by it. Now let's work to get the next number. So 1 times 3 makes what? 3. Repeat the process. 3 times 3 makes 9. Now we got to go in the backwards direction. So 1, and instead of multiplying by 3, we're going to divide by 3. So anybody know what 1 divided by 3 is? Yeah, it's a repeated decimal, so we're just going to keep it as 1/3, or 1 divided by 3. Always leave your answer like that. It's just prettier. It's more exact. Let's go ahead and do it one more time. Divide by 3 again. Well, if you remember, dividing by 3 is the same thing as multiplying by 1/3. So if you want to go ahead and go to the side, 1/3 times 1/3. Multiply the numerators, multiply the denominators. This is 1/9. Any questions? Can we graph this now? Always start at the origin. So 0, 0. And then what we're going to do here is plot the y-intercept first. So y-intercept is at 0, up 1. Then you go back to the origin, to the right 1, up 3. Back to the origin, 2 to the right, up 9. There we go. And now eyeball the other ones. -1, up 1/3, and -2, up 1/9. Kind of just eyeball it and then connect these points. And you know that it's exponential, so you're going to go ahead and draw a curvy looking guy. Okay, curvy looking graph. So you start with your roller coaster on the left and you go to the right. Is this exponential growth or decay? Growth. And the reason is, just by looking at the equation, you are multiplying by a whole number. That's how you know your growth. For domain and range, I always ask you to label, this is your left side, this is your right hand side, this is your bottom, and this is your top. And I'm going to ask you, domain is always left to right. Where is the arrow pointing to the left? Where's it pointing? The arrow is pointing to the left, and for a little bit or for a long time or what? Infinitely, right? Forever. So it's negative infinity too. And where's it pointing to the right?
Positive infinity.
Positive. This kind of extends a little bit outward, so it goes to infinity, right? Now, what about your range? Your lowest output? So it looks here like we never cross the y equals 0, right, axis. So we can have, but we can have 0.1, parentheses 0, good, because we can't equal 0, but we can equal the next decimal, which is 0.1, 0.111,
Infinity.
and it's pointing to the top forever. Good. All right. Okay, good. What's my y-intercept? 1. Are there any questions here? Exponential functions, we know that it's the domain is always negative infinity to infinity. The range varies depending on where you're at. Any questions? Are we ready for 16? Okay. So, for number 16, same idea. Our constant multiplier is now, what is it? 1 over 4 times 1 over 4 times 1 over 4. Okay? And our 0 spot is equal to 1. So I know that I can put the 1 there for 0, 1. And then I fill in the missing information. 1 times 1/4, right? 1 times anything is itself. Okay, 1/4. What about 1/4 times 1/4? Numerators times numerators, denominators times denominators. 1 over 16. What about in the other direction? You know that multiplying by 1 over 4 is the same thing as dividing by 4. So the opposite of dividing by 4 is multiplying by 4. So what's 1 times 4?
4.
And you could always check your work. And 4 times 4?
16.
There you go. And you can check 16 divided by 4 or times 1 over 4. So you should always keep that in mind. Some students like to draw a little division sign right there so they remember it's 1 divided by 4, right? But I hope that you know that 1 over 4 is the same thing as 1 divided by 4 or divide by 4. We're going to go ahead and plot these guys. Start at the origin, 0, up 1. Origin, 1 to the right, and eyeball it, a 4th. Back at the origin, 2, eyeball it, 1, 16. To the left, I get -1 up 4, and then -2 all the way up to 16. I know I don't have a y value of 16, but eyeball it. And it's a curve because it's exponential. Is this growth or decay? You hop on the roller coaster on the left side and you are going down the curve. So this is decay. Another way to know that is that you are multiplying by 1 over 4. So that is going to be decay. And then anybody want to raise their hand for the domain? McKenna, what's the domain? Okay, let me help you. This is left and this is right. And I'm going to ask you, where is the arrow pointing to the left? Is it going to stop somewhere or is it going to continue for a long time? Yeah, so it goes like this, right? It kind of extends. So negative infinity to where? Positive infinity, good. And then what about for the range? Since we know we can't cross to y equals 0 line. Anybody want to give this a try?
0 to infinite.
Just 0, parenthesis, right? We don't equal 0, but we can get really close to it, to infinity. Right? We get a bunch of these outputs really close to 0. They're getting smaller and smaller and smaller. But we don't equal it. Ow, I keep hitting myself.
So isn't that backwards? If I read it left to right?
This is from, oh no, that's domain. Sorry, domain. I didn't read it.
I mean from top to bottom or bottom.
Bottom
But
to,
it's decay. Doesn't it start at positive infinity and comes down to 0? Because it's decay.
that's a really good question. I always read it from bottom to top, from the lowest y value, which is 0 to infinity. But I do get your point where it's decay. Can I get back to you?
That's what.
But
If
personally,
you read it from left to right or thought about it, it's
Well,
decay. I get
but
it.
from left to right, it's correct. I mean,
Yeah.
because your x values are from left to right, which is negative infinity to infinity. But when reading the y values, you always read it from bottom to top, which is, I mean, I believe in myself, and I believe it is 0 to infinity. But I do get your point of confusion, but that's not how we read it for the y-axis. I can double check, though. I'll double check.
Oh, no, that's okay.
Okay.
Just looking at it, it just seemed like.
Yeah, no, we always read from bottom to top.
Infinity to 0.
No, it's a good point. It's a good point. I never really thought about that. All right, y-intercept is equal to 1. There you go. All right, guys. Let's go ahead and we have about 10 minutes, right? 12:43 Mondays all the way up to 12:55. Okay, so I'm going to continue the video. I am going to write down, you can just stay quiet the whole time. You need to watch this video at home, okay? So you might as well just start the problems with me, right? Work on them with me. So let's just go ahead and pay attention. Watch the video, finish the last 2 pages. The last 2 pages. Okay. Here are some rules, Kira. X to the power of 0 is always equal to what? 1. 1 block. Okay, the 0 spot always has 1 block. Now, negative exponents, we talked about this. The constant multiplier here in this case is x. And we see that the exponent is negative. That just means we went backwards. Okay, we don't know how many times. We went backwards an A amount of times. Could be once, twice, 3 times, 4 times. So whenever we have working backwards, you know that you're dividing by x, so you're multiplying by 1 over x. So why don't you write that down, 1 over x. And we see that an A amount of times. Okay, it could be, that number A could be 2, 3, 4, 5, even 1, okay? So I know it looks a little bit weird, so how about I do this? A, there you go. And for the product rule, we said that we could expand it all out. If we see x squared times x to the 4th, we could say x times x, and then times x times x times x times x. So we can add up all the, we can go ahead and see that we see the x multiplied by itself 6 times. So it's x to the power of 6. But we said that was a shortcut. All you had to do was look at the exponents. If they had the same base, you just add their exponents. The power rule, we said, was whenever you have an outside exponent and an inner exponent, you do outer exponent times inner exponent. So A times B. The quotient rule. We said that the quotient rule, right, is whenever you are x to the power of A matches with the base on the bottom, x to the power of B. This is x to the power of A minus B. That was the shortcut. An example was when you have x squared over x. They have the same multiplier, and you expand it out. That's x times x on top, and only 1 x down there. We said that the amount of x's on top decreases by 1. So 2 minus 1 makes only 1 x left on top. So the shortcut was just take the exponents and subtract. Are there any questions? Maybe I should do an example for this one too. X squared. You see this guy, the base twice, x squared times x squared. And you could expand it all out, or you could have used the product rule. But you know, this is, you see it 4 times, so it works out for us. It works out that 2 plus 2 makes 4. Or sorry, 2 times 2 makes 4. Maybe I should have used a different one. Maybe I should have used x cubed here, right here. Because I think a lot of students would confuse that. So x cubed, 3, 4, 5, 6, 7, 8, 9. There you go. And then this would have been, oh, I messed this up right here. Maybe I should do this. Let's start from scratch here. I wanted to do one where you had to use the power rule. So a quick example would be x cubed squared. You see that base, x cubed 2 times. There you go. Multiply by itself twice. And you could expand this out 1, 2, 3, and then 1, 2, 3. X's multiplied together. And you see the x 6 times, x to the power 6, right? Or in other words, you see x multiplied by itself 6 times, so x to the power 6. So you just multiply these 2 guys, the 2 and the 3, and that makes 6. So that's just a nice example. These are just amazing examples. Let's try one out. Let's do 17. 17, we can use the rule, and you look at the top, right? Always look, and it's product rule. You could expand it out, but I will tell you right now that all you have to do is, since they have the same base, you add their exponents. So this is x to the power of 29, and you are done. It saves you a lot of time. And then number 18, I would say I'd like you to separate or put parentheses or dots, like, right, that represent multiplication. I personally always go with dots. Like, it's just, I know they're invisible, they're there. You're multiplying. Y to the power of 0 is always equal to 1. So I'm going to rewrite this as negative 18 times x to the negative 5 times w to the 6th power. I noticed that I have different constant multipliers. I got the negative 18, I got the x, and I got the w. Negative 18 has an invisible exponent of 1, so that one's good to go. W to the power of 6, that one has a positive exponent. I'm good to go. There's no other way of rewriting it. The only one I can still rewrite is x to the power of negative 5, okay? Negative 5 in the exponent, that means I went backwards. That x is not multiplying by x, but dividing by x. So I know that this is represented as 1 over x, right? I multiply by 1 over x 5 times. 1 over x times 1 over x times 1 over x. And that's 1 over x to the power of 5. And then don't forget to bring these guys down. They're still in the numerator. Whereas x to the 5th is now in the denominator. So, and if you would like to make this all nice and pretty, this is negative 18 times w to the 6th over x to the 5th. Or you could have used that cool shortcut. You could have just moved it to the bottom. Number 19, we used the quotient rule. X to the power of 7 minus the 15. This gives you x to the power of negative 8. And don't forget, this means you went backwards. Instead of multiplying by x, you went and divided by x. So you did 1 over x times 1 over x times 1 over x times 1 over, so 1 over x to the power of 8. You did that. You moved to the left 8 times. So divided by x, divided by x, divided by x. Okay? Another way you could have done this is just expand it out. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me see if I can move this down a little bit. And then you know that you have Same copy on top, same copy on the bottom, and you get a nice number down there, x to the power of 8. 1, 2, 3, 4, 5, 6, 7, and I think I crossed out one more. There you go. All right, guys, watch the video, and I'll have questions 20 all the way up to 29 done. Thank you so much. I do have a practice exam online if you would like to start it. If not, we can start it on Tuesday. Thank you. Okay, so for number 23, we have a fraction, okay? And I told you guys the best way to do this is if you look at 16 over 4 as one little unit, then use x to the power of 5 over x to the power of 3 is another little unit. And then the last constant multiplier that's the same is y squared over y to the power of 6. So we go ahead and separate them pretty much. 16 over 4 times x to the power of 5 over x to the power of 3 times y to the power of 2 over y to the power of 6, okay? We're allowed to do that because in multiplication, right, when you multiply fractions, you multiply numerator with numerators, denominators with denominators, right? So we get essentially the same thing. They're equivalent. Always keep the constant multipliers, right? The x's with the x's and the y's with the y's. So let's get straight to it. Let's use some of the rules we've learned. 16 divided by 4, there is no rule to this. We just plug it into our calculator and get what? 4, right? Because 16 divided by 4 is 4. But now we have x to the power of 5 over x to the power of 3. Yes, there's two ways to do it. You could either do it the long way, 1, 2, 3, 4, 5 x's multiply together, and 1, 2, 3 x's multiply together. And you can see that this is one whole, this is one whole. So you only have x squared left, right? I see the x multiplied by itself 2 times. Now what about y to the power of 2 over y to the power of 6? You could do it. Yeah, you can do it the long way, right? And you say, okay, that's one whole, that's one whole. So I'm just left with 1 on top, right? Over 1. So you could either do the subtraction, so 2 minus 6, that's usually what I do. 4 times x squared times y to the negative 4. But we had more y's on the bottom. We know that this guy is the same thing as dividing by y because you went in the backwards direction. You went divide by y, divide by y, divide by y, divide by y, which is the same thing as multiplying by 1 over y times 1 over y times 1 over y times 1 over y, which is the same thing as 1 over y to the power of 4, 4 times to the left. Therefore, your answer is just 4x squared, because these are all in the numerator, over y to the power of 4. Are there any questions?
Is this the test?
Yes. Now we're going to go to number 24. 2 ways to do this. The quick way is to, does anybody want to share what their answer is for this guy? Yes, go ahead, David.
W to the 4th over v to the 3rd.
Correct. You just swap places. This one goes to the numerator, this one goes to the denominator, and change the sign of the exponent, just like Riley told us earlier on in the week, last week. So another way to do it is you know that you're going in the opposite direction, so you're dividing by v, so 1 over v, you see it done 3 times, and then 1 over w to the power of 4, right? Because you're dividing by w, right? Divide by w, divide by w, divide by w, divide by w. So that's 1 over w to the 4th. And you just keep, change, flip. Keep, change, and flip. And this gives you 1 over v cubed times w to the 4th over 1, which is exactly what David said, w to the power of 4 over v cubed. Very, very good job. Keep, change, flip. Okay. Okay. Let's go on to the next one, number 25. We got 4x cubed to the power of 2. Two ways to do it. Just remember, there's a constant multiplier of x and a constant multiplier of 4 to the power of 1. You only see it one time. So let's do it the shortcut way. It's just outside exponent gets multiplied to every inside exponent. So that's 4 to the power of 1 times 2 times x to the power of 3 times the outside exponent, which equals 4 squared times x to the power of 6, which is 4 squared is 16 times x to the power of 6. If you wanted to do this the long way, you would have noticed that you see this 4x cubed 2 times, 4x cubed, and then again 4x cubed. You bring the 4's to the front, 4 times 4, and bring the x cubed times x cubed, and look, you get the same answer. Now, let's go ahead, and we still have a few more minutes. So I am going to, no, class ends at 2:25. So I am going to continue with the next problem. We are going to use either equation A, B, or C. Okay, A, B, or C, depending on the scenario. Luis deposits $2,150 into an account that yields 7.5% interest annually. So you earn that. How much money will he have after 20 years? Okay, round your answer. So let's go ahead and write down our initial value. So this is our A, and I'm going to highlight it. This is our rate, right? And I'm going to highlight that too. And then we also have the time, which is 20 years. So let's write that down. A equals 2,150. The rate as a decimal is, move the decimal over twice to the left, 0.075. And then we know that our T is 20 years. So 3 things that they give us. And since we're making money here in the account, right, it creates a 7.5 interest annually. So we know that we have to use, remember Chelsea, she used that shortcut. So it's A or B. But since we're making money out of this, it is A. So we're going to take y equals A parenthesis 1 plus r to the power of t. Replace the A with 2,150, 1 plus, the decimal is 0.075 to the power of 20. So our friend Chelsea actually helped us calculate this all very quickly. I am going to use my calculator to show you how to do this. I'm going to type in, so if you have your calculator, 2150 parenthesis 1 plus 0.075, close the parenthesis, and make sure you use that little caret symbol. My caret symbol actually puts it up on top, right? I don't actually have the caret symbol. It actually, my calculator is a little more advanced, and it puts it in the exponent, and there you go. So I get the number 9,132. And since it's money, we got to round to the nearest hundredth. So 8, okay? 88 cents. Are there any questions? Can we do the next one together? A boat depreciates. Okay, that means you decrease, right? That means you're going to either use, so we got to make sure we use A, B, or C, and then the one with the minus sign. In value every year by 15%. So let's highlight that. That is my R. If the boat is worth $200,000, so that is our price, our initial value, how much will it be worth in 5 years? So we also have the time. So let's go ahead and pick the right formula. We know it's depreciating, so it's going down. So we are going to write down the formula. Y equals A times 1 minus R to the power of T. A equals 20,000. Our R equals 0.15 and our T equals 5. Plug this all in. All right, guys, so I'll be plugging this in to 200,000 parenthesis 1 minus 0.15 parenthesis to the power of 5. And then you should get 88,741.06. Thank you so much, guys. Have a wonderful day. Don't forget to look at the video on YouTube and make sure you check your answers. Write down the work and turn it in. Thank you so much, guys. All right. So number 28 says the recycling plant currently has 80 employees. This amount grows by 8.5% every year. How many employees will be at the plant after 12 years? Round your answer. So let's go ahead and highlight important information. 80 employees, right? That is our current amount. And this amount grows by 8.5, so that is our rate. And let me use the correct highlighting colors. There you go. That is our A. That is our rate. But we have to turn it into a decimal. There you go. And how many employees will be at the plant after 12 years? So that is the years. I used the color red here. So we have A equals 80. R equals, as a decimal, 0.085, and our T equals 12 years. So it's growing by 0.085, and we don't see the word compounded, so it's either A or B, but since we're growing, we use A. So equation A is Y equals A times 1 plus R to the power of T. Go ahead and substitute. And the way you plug this into a calculator, make sure you put the caret symbol to the power of 12. And let me show you what that looks like on my. All right, so we get 80 times, and you could plug 1 plus 0.085 in there to the power of 12, and you get 212. If you round to the nearest hundredth, but you can't have 93/100th of a person, so you round to 212. Okay? Employees. All right, let's go ahead and do number 29 together. Lila puts $13,000 in a bank account, so let's highlight that real quick. So 13,000 initially, and earned 6% interest. That is our rate, and we can write that as a decimal. Move it to the left 2 times. Here we go. Let me see if I can. 12.06, and it's compounded monthly. Okay, so that word compounded, we're going to use the last formula. How much money will be in the account after 8 years, and that is our time. So lots of the same information, but just the keyword. So A equals 13,000. Our rate is 0.06. Our T is 8. And then our number of months compounded, since it's monthly, N equals 12. Okay. So let's move that over there. Let's plug it into our formula, which compounded is the last one. y equals, and I'm just going to call this a equals a times 1 plus r over n to the power of n times t. Just substitute 13,000 times 1 plus 0.06 over 12 times 12 times to the power of 12 times 8. You plug this all into your calculator, and the way you're going to do this is put double parentheses around this guy, and then make sure you do this guy in your head. So 12 times 8 is 96, okay? So let me show you what that looks like. So on your calculator, put 13,000, parenthesis 1 plus, put another parenthesis, 0.06 divided by 12, that's the forward slash, parenthesis, and then another parenthesis to the power of, and I'm going to put 12 times 8 is 96. And it gives you the correct answer. It gives you 20,983.86. That's how much money you'll have. Okay? Thank you for watching.